Ayush actually spoke at BeerCon3, kind of similar to Dan and Josh and Nikos and Will from earlier. I'm really looking forward to this talk. Ayush, do you want to spin up your
Yeah,
slides?
sure.
Cool. So yeah, Ayush is going to be talking to us about automation and application security. I need to put my teeth back in. I haven't been drinking. It's not neat vodka. But no, I'm really looking forward to this talk. Ayush, take it away, man.
Thanks, guys. Hey, everyone. So I'll be talking about automating application security today. I am Ayush. I work as a cloud security specialist engineer at Cloudl. I've spoken at a bunch of other conferences. So BeerCon3 was the first one, and post that I've like tried to keep going and like present at other conferences as well. Most recently, we said Sincere. And in my free time, I've been volunteering as a chapter lead at OWASP branch as well. So what lies ahead, right? We'll try to like answer a few questions essentially to get to what we are like looking forward to in this talk is to essentially automate application security. So we'll begin with like what is application security in the first place, because it's like a really old realm in InfoSec itself. So we'll take a look at what has changed in application security over the years and how do we utilize these changes towards our goal is that is for automation, right? We'll take a look at a small demonstration about how we can do like small nuclear tasks, going about putting in security processes into like an automated workflow. And then we'll answer a few questions that might come to your mind during or like post the course of this talk. So why would we want to change what already works for you folks, and what you can and cannot automate? And finally, we'll just draw some conclusions that will come at the end of it. So what is application security? This is the Wikipedia definition. So, but in simpler terms, any process or any action taken that improves the security posture of your application or products essentially by various methods, right? So the definition defines finding, fixing, and preventing. So any of these things essentially is application security, and it can be put in different stages of the SDLC or software development lifecycle. So it could be as early as the design phase or as late as the maintenance or upgrade phase. And it's mostly prevalent during like the development and deployment stages because pen testing, right? So that's where it typically happens. So essentially, we are developing preventive measures. Application security is the development of preventive measures. I say preventive because ideally, if we have figured something out that's wrong in the aspect of security, we would want to prevent it from happening again instead of having to like fix it every single time. So developing preventive measures can be included in various stages of software development lifecycle. So again, because we can think of security issues as early as the design stage, right? We could take a look at an architectural diagram and figure out if something could go wrong here. So we could put in preventive measures then and there itself. So the various stages of SDLC. It's a crucial aspect of security by the virtue of that most of the things that we do protect in security are applications in one way or another, right? If you take out applications, there's not a lot of things left to protect. So it's obviously crucial. And according to me, again, the idea is to, or the goal is to maintain the CIA triad, which is confidentiality, integrity, and availability. So a security issue essentially violates one or more of these three characteristics, and the fundamental goal of application security is to prevent that from happening. So some examples of application security would be, let's say, static application security testing or dynamic AST or DAST. For instance, SAST is essentially where we have a bunch of known bad coding patterns. So if you're familiar with Python, there's a function called eval where you can just put Python code as a string and it will allow you to execute that, right? Now, in the case of a user control string, that is like a potential bad case where an attacker could like inject some code that could do something bad essentially. So yeah, that's SAST. But because we have like known of this, we know of this pattern that it exists right now, so we could like check for it before we like, let's say, push our code to deployment or like to package it and then send it off to wherever it's supposed to go. So we have different kinds of these tests that adhere or like fall under the umbrella of application security. Now, what has changed? So application security is almost as old as the security industry itself, because that's what we're protecting, right? Different kinds of application in their various forms. So what has happened that we have like decades worth of experiences of figuring out these bugs, exploiting them, and also preventing them from happening or defending against them at least, right? So at the current stage that we are at, we have been able to consolidate all of these experience that we have had over the years through research or like through different kinds of ways into databases. So we have NVD, we have like a database of CVEs and everything. So what this allows us to do is like classify these vulnerabilities or security issues that we've collected in different forms, right? And thus comes classification. So we can classify them on different bases based on the characteristics that we choose to classify them on. For example, one could be severity. So an RC would be like a very severe bug, but a dangling S3 bucket name or a domain pointing to an S3 bucket might not be like a higher critical severity, depending upon the context, obviously. But for the instance, let's say so. And there could be another case where we classify them together as the same class of bugs, but different aspects, like still differentiate them in between. So we could have excesses, but excesses could be further divided into self, stored, and reflected, right? So all of these still fall under the classification of excesses bugs, but then they are still different based on their specific characteristics for them to be segregated on whether it's like a stored excesses or a reflected excesses and whatnot. And once we have classified them based on these characteristics, the same characteristics can be used to like standardize a testing procedure for them, right? So for the most vanilla case that most people would come through into the security industry is like exploiting SQL injection, for example. And the most simple thing that most blogs or any starter post about SQL injection would be to like add a single quote to the end of a parameter, right? At the end of an address URL or something like that. And if it throws you back an error saying SQL or some sort of an error, you have potentially found an SQL injection. Now, this is we can characterize this as the simplest way to figure out if we have a potential SQL injection on our hands or not, right? So this is the standardization of testing procedures. Obviously, it's not as simple as just adding a single quote at the end right now. It's way more comprehensive, and because of that, we have now tools. We with ourselves have like tools and frameworks to do this for us. So we have again, coming back to the SQL injection example, we have SQL map with us, which is, I guess, the most comprehensive tool you can use to like check for SQL injections, right? Then we have SNCC, which is even like a step further. You can integrate it directly with your repositories on GitHub and other places, and your alerts get sent to your email and your Slack or whatever, where you would want to have them. And lastly, the advent of DevSecOps itself, right? So DevOps is relatively new itself, and then DevSecOps is its even newer cousin. But the idea is to shift security to the left, which is to push security and security processes as further like on the left side of software development lifecycle, or as early in the software development lifecycle, to essentially like prevent for the most part, I think from a business point of view, to like save costs, because fixing a security bug post development or deployment is obviously higher, much higher than it would have been or during development or even in the architectural phase, right? So something like that. So coming to how do we utilize these changes? So we have figured out a bunch of these things that we just took a look at the last slide. So how do we go about actually automating a process, right? Or how do we start with it? So my personal suggestion is to like pick a single scenario, right? A single scenario, I mean a single particular case or a security issue that you want to tackle right now, or perhaps is the most prevalent in your case, and understand the context of it. By context, I mean whether it actually is a security issue, depending upon your product, where it's supposed to be shipped, if it's an internal product or something like that, and then create a standard process for it, right? So if it was an SQL injection that I was testing for, and the most vanilla case at that, the process I would call back on again was the fact that I'll just want to add the single quote at the end of the URL at the end of a parameter, and if it throws back an error, it essentially I would assume that it's a SQL injection, right? And once I've actually created that process, I would want to test that process instead of having like wasted time to automate it and then find it not working at all. So after creating the processes, we want to test the processes to like sieve away all assumptions or anything, any cases that we might have missed, and essentially making the most the standard process that we want to essentially automate at the end of it more robust, right? Once we have done that, we have tested the process that it actually works, we can automate. Now automation can be done by various means. So you could use bash, you could use python, you could use tools, frameworks, and everything in between, whatever feels most comfortable for you to work with and is ideal for the scenario. And once you have done that, then we can move on to the next scenario. So I suggest like going more of a breadth first approach instead of depth first. Like trying to automate a process end to end might become a very challenging thing, because a lot of these processes, especially in security, might require manual steps or analysis, right? Like to look through a report or find false positives that are computers or like algorithms can't yet. We'll talk a little bit more about in detail about these particular limitations later, but yeah, that's how you'd want to go about doing this. So like pick a process, create a process for pick a scenario that you want to like create a security process around, create the standard procedure for it, test that procedure, automate, and then move on to the next one. So I'll show you a quick demonstration of something that you can do with GitHub workflows. These are simple YAML files that you could write your scripts essentially in a YAML format, and they'll do a bunch of things for you. So this particular script, 36 or so lines, is simple enough. So there are 3 stages. You don't need to worry about the YAML at all. It's fairly simple to pick up, and most of these are just bash commands. Put it in the syntax that GitHub workflows require them to be in. So I installed Git secrets, which is a tool that check for regular expression patterns that you've provided and finds them in your commit history, essentially, to figure out if there are any secrets or confidential information that you might have committed to your code, right? So I install Git secrets, run a scan with it, and then upload an artifact, the report as an artifact to GitHub itself. Now, GitHub workflows is really cool with something like this, is because it gives you a lot of functionality out of the box and for free. Now, obviously, the limits are based on the tier that you have GitHub on. It could be enterprise or your personal thing or the free one, but it gives you a lot of things out of the box. Now, let's take a look at this other one. This is shift left analysis. So the fun fact about this one is that I don't even have to write it. GitHub Actions has something called Marketplace. You could go there, pick a few of the workflows that you have that you want, which are pre-written for you, and clicking a button essentially would add this workflow to your repository along with like other cool things. And it does something similar. It performs a scan and it will upload a report as a artifact to GitHub again. Now let's take a look at the actions themselves. So depending upon the event that you trigger, like set the trigger for, it could be a commit, it could be a release, creation of an issue, something like that. It will trigger the workflows accordingly. And here you can find the logs and all. So what happened? This is your shift left scan that we just looked at. It does a whole bunch of scans, different kinds of things, dependency checks. It found one issue, and then this is the overall report, right? So the dependency scan failed, the secrets audit failed, and the rest of the 3 things that it does passed essentially. And finally, it also uploaded the report. Where we'll find the report is something we'll take a look at a little bit later. And this also has a security tab, by the way. So you could do your security issue management right here in the GitHub repo itself, instead of having to use a standalone tool, let's say Defect Dojo or Jira or something else. But again, it's a matter of preference. Yeah, it's not necessary that you use this. This is the Git secrets one, the one that I wrote. And yeah, these are the commands that we had in the last stage that we want to run, and the report got uploaded to GitHub Actions. So where would you find the report is if you go back to the workflow where it would run and just scroll a little to the bottom, you will find that under artifacts you have this report, right? And the another good thing about GitHub Actions is the fact that not only can you store these reports or text files, you could also package your applications and keep them there. So it could be Docker images, your node packages. You could just package it and use this as a package repository as well, and your organization could host all of them, right? So coming to why would you want to change something that already works, right? So most of our organizations would already have security processes in place, and they would obviously work, right? They have been working for a really long time. So why would you want to change, or why would you want to automate in the first place? So it automation, obviously the first and foremost thing is reduces human toil. Now toil can be defined as any activity that is essential to a process but does not require like the actual thinking capacity of a human's brain, right? So think of it as to perform an SQL injection, you need to know that it exists, right? So to like do some time-based thing or like error-based SQL injections, you first need to figure out that it actually exists. Now, we have tools, SQL Map, for instance, that can tell us that instead of us having to like check each endpoint manually, right? So it's essential that we have to do it if you're not using SQL Map, but it's a frustrating job. Now, it could be compared to something like we have a simple enough task that we have to do, like enter a bunch of rows in Excel, right? For example, we have a lot of entries in an Excel and we have to capitalize each entry. Now it's a simple enough task, but after, I don't know, 200, 400 entries, one might get tired, right? And frustrated and is bound to make errors. So it also reduces the chance for human errors. And by bias, I mean, depending upon the engineer, it could also be the case that he has a bias for a certain kinds of bugs. So he or she could say that, let's say, a class of bugs is supposed to be classified as critical, but in our context, it might not be the case. We might only consider it as a medium or a low severity bug. So having that engineer bias towards a particular bug could essentially and make it misrepresented in our vulnerability managed platform, or like wherever we are trying to track these issues, right? Security issues that we have identified. So adding automation, giving it a process to figure out what kind of a severity would also do away with the bias that one engineer might have, which would differ from one engineer to another. And taking away all of these errors and frustration based issues that would come by performing essential but grunt work ish jobs would make the system robust at the end, right? Because we are again doing away with errors. Now by being robust, I do not mean that it will work 100% of the time. Cases are bound to change, some things are bound to break, and it's an eventual process to come to like a near perfect thing. But robust does not mean like 100% perfect thing from the get-go. At the same time, it also does not mean that it will break most of the time, right? That's the whole point of testing our standard procedure that we created earlier, and then slowly, iteratively building on top of it to fix any edge cases that we might encounter later in the scenario of actually using that automation. Now, because it's robust and we're doing away with errors, we enable trust for further automation. So once we see it working and once we see the benefits that we get out of automation, be it security or in general, we would want to automate like other things, right? And then that light bulb clicks key, okay, I can automate this thing also, I can automate that as well. And then you can identify avenues for actually putting in automation where it seemed like it is, I guess, too much of an effort, or maybe you didn't even realize that this particular process can be automated with a little bit of effort, but in the long run it will save a lot of time, right? And the most important of all is the fact that any kind of automation would essentially give the engineer, the costless security resource in the team, time, right, to do much for, for far greater things as compared to like checking for vanilla cases of SQL injection and so forth. So taking away grunt work from the engineer would allow him to actually put in thought and effort into a more quality assessment of things that he's supposed to do, be it research work or an actual pen test, right? And it would also allow him to like take things further. For example, if we have a tool that tells us that an XSS bug already exists, right, with on an application, the engineer could just take that fact and like take it further, instead of just not having time to do that, because previously he was actually finding the XSS in the first place, and that would cut away most of the time because all of us work on a deadline in some way or the other, right? So freeing up the costless security resource, the engineer would allow him to like focus more on the research work, finding or chaining different kinds of bugs and bugs together to do more sophisticated attacks that are like tools are currently not capable of. And yeah, I mean, that just like is worth in itself. So what can we automate, right? There's a lot of things that we can automate, but when we talk about automation right now in this talk, we'll talk about security related stuff. So security testing, obviously, that does not mean that you can do away with your pen testing team, because again, tools are not as smart as we'd like them to be at this point, and they probably will never be as smart, perhaps, I don't know. So yeah, security testing for one, if not in the entirety of security testing, is at least some part of it, where we are finding these low hanging fruits that we can get just from tools, because low hanging fruits are essentially what we consider right now as the easiest bugs to find, right? And they are the easiest ones to find because there's a lot of literature behind them, and we have a lot of cases where we could like identify these bugs through. So a lot of security testing can be automated, parts of it and stages of it, especially even if it's not like end-to-end automation for the testing. Then reporting and alerting of issues. So once we have figured an issue out, we could add a few more lines to our automation to put it in a platform, right? It could be Jira, it could be Slack. And if you're also able to like put a map of sorts key, if this is the class of bug, make it consider it as a severe bug, or like a critical severity bug, so we can alert based on that on our Slacks, phones, emails, and whatnot, right? So alerting is another place where we could alert to multiple sources at once, depending on the kind of bug we're encountering, the kind of checks we have in place. Then vulnerability management, right? So we could also put it in places, as I said, Jira or Defect Dojo, for managing these vulnerabilities, and people can just take it up from there, instead of us having to like manually go through a report, add findings to these tools and so much more. So yeah, I mean, we can automate a lot more things, but these are good places to start because they are like kind of grounded in a lot of toil, right? A lot of grunt work that you'll have to do, like reading a report and then actually adding those vulnerabilities to a platform, or alerting or reporting. Security testing obviously has like a lot of grunt work involved in like setting up environments or a bunch of other things, right? What cannot automate? So unstructured processes, the simplest one. So the automation relies on some form of code, right? So we need like well-defined steps to do like any kind of automation. So any unstructured process that has like a very convoluted set of steps, right? Or diluted set of steps that is very dynamic and changing in its nature. It's not like a deterrent for automation, but it just makes it way more complex to actually implement it. So it might be a good idea to like get our hands dirty with like actually putting in simple automation first in the first place, and then adding iteratively on top of it as a layered approach, instead of trying to automate the entire workflow at once, as we talked about. Then testing for sophisticated classes of bugs, right? When I say sophisticated, these are essentially the bugs that most tools would not find, or tools would not find in general, but the ones that require a human to actually put his mind behind this bug, or like perhaps chain them together to create a even more severe bug, or like a bug that is of a higher severity, right? Because this context of two different bugs, the tools are not really that great at yet to like merge them together and figure out what they can do with them together. But a human, it's as depending upon how experienced the pen tester is, it's a matter of like muscle memory, right? So something like that. And anything that requires manual analysis, so of course most of the tools will generate some sort of false positives, and these false positives are required to be reviewed by a human at the end of it. So if a human is involved in any place of the like the automation, it cannot be end-to-end automated. It cannot be true automation, right? So even if it's like him like clicking on the button at the end of the analysis and then it still works, but that particular stage is still manual, so it's not true automation. And essentially what we're talking about is partial automation, right? And that's the, I guess, light at the end of the tunnel, in a way, that even if something is not automatable from the first step to the end, there are places in almost all processes that we can find that we can automate for. Now whether it's a good idea to go ahead and do that is dependent upon the context. It might be a simple enough job that would require 2 seconds of your time, for example, just like sending an email, I don't know. If that's not too much of a time saver, then sure, we would not want to automate that. But again, identifying these processes is the first step to figuring out what actually is grunt work and what we can do away with to like save not just time but like effort and energy towards finding more relevant security issues instead of just the bare minimum ones that we can find because of the constraint of time, right? So as conclusion, we looked at what is application security. So any aspect dealing with application that improves its security is application security. We took a look at how over the years it has come into like this form where we have consolidated and we have a structured amount of data about different issues and classes of them, and we have created tools and frameworks out of these issues to make our lives easier, essentially to test them and to identify them, perhaps defend against them as well. Then we take a look at how we could create these automated processes as a let's say a checklist, right? And then we also took a look at a simple demonstration on how not complicated it is to actually put it in place if we just break it down by process, right? So secret scanning was one single process. Then we had another tool which would even take care of writing that workflow file for us. But like the first one that we took a look at, which was the secret scanning one, we could add n number of workflows that would just test for these things individually and generate a report for us at the end of it. We took a look at different kinds of benefits, which was robustness, reduced errors, and obviously the best one of them all was the fact that the engineer has more time on his hands to like do stuff, right? And finally we took a look at automation and the limitations that come to us with trying to like implement automation for different kinds of processes and in different places, right? So thank you folks for your time, and I'll take any questions if you guys have any.
Cool. Okay. Thank you very much, Ayush.
Thank you, people.
Lots of great. We are people. Thanks for that. Yeah, really interesting talk. Application security is where I started out my career in security. Sean, you are an application security guy even
I
today.
am indeed.
Can you tell Hail Nolly to throw in her question if she's got a question?
Well, Nolly's a guy that was doing a talk earlier, if you were paying attention.
I said guy.
No, you said ask her to put a question.
I didn't say that.
You did say
I said him.
Ian, we need to have a talk.
Yeah, so if you've got any questions, just put them in Twitch.
Yeah, stick them in the Twitch.
Stick him in the Twitch.
Any
There's a big question coming.
Hopefully there's a question coming. We've got a bit of time before our next speaker.
Yep.
Sean's got an idea about talking about fear, uncertainty, and doubt. So you lead on it. It was your idea, and then we'll chip in.
Yeah. So, no questions yet.
Okay.
Just making sure there's none there. So yeah, I thought we'd just do a quick impromptu talk on FUD.
No, but we got a question.
Oh, we have a question.
Yes. It's how do you prioritize which processes to automate? And
Okay.
that is for our speaker, Ayush.
Ayush,
Ayush?
So
that
That's
question
what
is
I
for you.
said.
yeah, so I would suggest to start off with the simplest one if we are starting out for the first time to like put in automation, because it's a little difficult to like think of all the cases that we'd come across, right, while putting in this automation in place. So start off with the simplest part of the entire workflow that you're trying to automate, and then take it from the an iterative process to add different, let's say, edge cases to your automation in an eventual manner. You don't need to be like perfect in the first case, like we talked about the SQL injection thing. So first could be just the identification of it, and then you could try to like figure out if you could identify the kind of SQL injection, and then if you could maybe add it to your security management platform, alert on it, and something like that.
That's great advice. Absolutely. That's good. So, if there are no further questions, we'll say goodbye
Sure.
to Ayush.
Yep.
That's what I said. And we're going to go with Sean and his topic of emergency topic. I guess.
Oh, we've got another
Of
question.
fear, uncertainty, and doubt. Of course, somebody's going to ask another question, just as we said goodbye.
All right.
Oh, but he's still with us.
Yeah.
So the question is, what are some of the common tools for automation, and how do you validate the results? Interesting.
So while putting in, I mean, the common tools, it depends on where you are. So, or where you'd want to put the automation. A lot of it, if you're like using, let's say, Jenkins or Travis CI, you could put your automation there. If you're already on GitHub and Bitbucket, and a lot of us use that for, let's say, deployment and stuff, right? With pipelines and GitHub Actions, as we just saw in the demo. You could put in a lot of things there, like let's say a pre-deployment checklist or security checklist of sorts. You could write workflows for that and then alert based on them. So there's plenty of tools. It depends on how you essentially, what's your pipeline like of the design to like deployment of your application. And sorry, what was the next part? The other part?
It was then, how do you validate the results?
So that's kind of a precursor to writing that automation. No, you will not write an automation without knowing what the end result, or having at least some idea of how the result should look like. So it's like essentially, if you develop a software, you know at the end of it what you want it to do, right? So while you're writing automation, you know that at the end of it, it should help you identify, let's say, and if a secret is in your code committed, right? Or if it doesn't identify one, then you need to figure out if it failed because I mean, if it failed to identify one, or your code does not actually have one. That's a different process, but the results that you'd want to see at the end of it are you would have some idea before you write the automation itself, because I mean, how else would you validate a result that you do not know, right?
Yeah, that's a very good point.